Well, good morning, everyone. Thanks for getting up so early and coming down to hear the presentation on domain-driven design with Spring and vFabric. My name is Wes Williams. I'm Senior Architect with EMC Consulting.
Hi, I'm Vaughn Vernon. I'm the author of Implementing Domain-Driven Design, a new book that's available in rough cuts right now on Safari Books Online. Just go to safaribooksonline.com and search for Implementing Domain-Driven Design, and I'm helping Wes as an independent consultant.
And so I'm grateful. So Vaughn and I paired up to give this presentation for you. The application we'll be demonstrating is NanoTrader, now this week named SpringTrader by VMware. And what NanoTrader or SpringTrader now is a best practice reference architecture for vFabric in the entire application stack. So a lot of credit to the architect, Brian DeSalle. He's here in the room for coordinating all the efforts to get all the experts from the various disciplines of the application stack from top to bottom. And it actually works. It works well, and we'll show you a demo of it a little bit later. One thing I wanted to preface before we begin is that we're going to, you've got the best of the best for every tier of the application architecture for all the various physical tiers, but we're going to analyze it from a different perspective, that of software quality through the lens of domain-driven design. So and so none of the observations are intended as criticism of the excellent work that's been done. But they're observations of the kind of code that we write, how we can improve, or maybe things are just fine. Since it's a financial application that we're talking about of necessity, I have to introduce maybe one slice of my background. So I'm in the role of domain expert. I entered financial services in 1981 as a programming consultant for very large enterprise companies. I've served in the role of software architect on one of the big four Wall Street investment bank front offices, and program trading. Program trading at the time handled 25% of all volume on Wall Street. So it's big data, fast data. I've been involved a lot in algorithmic trading for a global securities firm. And along the way, I got the SEC securities license, managed my own hedge fund as a hedge fund partner with a group. And so that's my background as a role of domain expert for financial services. So if I manage a hedge fund, why am I here in technology? Well, I like technology. So, and a brief background about us as presenters. I started back in the days of big mainframes, and Smalltalk is common in our background. Now, what made Smalltalk interesting, at least from my perspective, wasn't so much the syntax of the language, but there was the community of thinking, of best practices. What's the best way of constructing software, if there is such a thing as best patterns and designs. Now, the Gang of Four book came out in 1994. It just contained a small footprint of all the patterns that was in the Smalltalk community at the time from the 70s. And of course, we come on down the line to where we are today. But whatever happened to software craftsmanship, domain-driven design, that community of thinking that was back then? Well, Microsoft had a whole lot of success with Visual Basic property sheets. And then we had the Java Bean spec, the abuse of that. A lot of developers over the last decade not really taught software craftsmanship in computer science courses. Emphasis on quality. Outsourcing a company with low retention periods, and the big one-year bonus over the last decades, because so many individuals, not just corporations, but over the last decade, a lot of individuals have been investing in the stock market, causing tremendous influx of cash and equity at the top, and so there's a lot of pressure. Hurry up, just do it, just get it done. How long is it going to take? And so people are under pressure to deliver software fast. That's a little ball of mud, right? I should have blown that up. Must software really be subject to entropy?
What's the abuse of the Java Bean spec?
I'm going to go into that in a little bit. Yeah.
It's good. It's a very good question, and it lies at one of the hearts. Now, you may have more to add to this. This is by no means comprehensive. Now, from my own experience, the importance of software quality, the quality of code we write, can affect the bottom line of a company. This is one financial firm where I happen to be put in a lead position of the golden egg, somewhere around in here, of the company. But this was a company specializing in computerized trading, and they commoditized it, and they made a lot of money, and their clients made fortunes, tremendous amounts of money. Now, what here in the dark line that we see, this is the Dow Jones Financial Index, and of course you can see its meteoric rise there in relationship to that index. But something's happening here where the financial index sort of recovered and is going sideways here. This company continues to decline. Why? Well, I happened to be on this project at the time, and it was truly a big ball of mud, because you had business rules mixed in with application coding and security and file handling, hundreds of thousands of lines of code. And the concept of an order was spread out all over the code base. And so what was happening, and maybe you've seen this as well, is that when a developer would go in, hurry up, we got a client, needs this change quick. He'd go in, he'd know exactly where to go, make the change, it'd go to QA, and then QA would find a bug somewhere else in the code that was unanticipated, had no unit tests around it, no automated QA testing. And so because of the lack of unit tests that had been through the history of this application, QA didn't trust the quality that was coming out, and so QA cycles, release cycles, started to grow. It took 3 weeks just for QA to test the application. And so the hundreds of clients that were requesting fixes, new features, why is it going to take so long just for this simple little fix? Well, you know, and so clients can only put up with those waits for so long. Now, I happened to be on the inside. I knew the business model. I knew how things were done, and so I could relate. I could say with pretty good certainty that this is at least partially a result of software quality. So what we did was we trained programmers and how to write encapsulated code, started surrounding it with testing frameworks, but then EMC Consulting, I wanted to be in cloud, and that's why I am where I am today. And so around that time when I was dealing with software quality, Vaughn called me and said, hey Wes, can you proof a few chapters of my upcoming book? Now, domain-driven design's been around for almost a decade, but I said sure. And I started to analyze it, and I said, you know, I'm impressed at how domain-driven design has progressed. And so we began to wonder, does this have application for modern programming? So when a project manager or executive comes up and says, just do it quick, we're thinking about our bonuses, just do it quick, we're thinking about money, can we have quality? Are they mutually exclusive? Or can we have both? And if we can have both, how can we do that? That's what we're going to talk about today. So who needs this information? We do. Here's a slide I put together this week where this is an application service. And this is a sample off a web page, how to create domain objects and implement the business logic. So we got an application service looping through products, but notice that this is business logic. So we have business logic in an application service. This is procedural code. It gets information, makes decisions. There's another pattern called tell, don't ask pattern, and that's to move the business logic into the product itself, and then just dispatch the percentage into the product, and let the product increase the price.
In case you're interested, by the way, you can find this original work in a book by Alex Sharp. It's called Smalltalk by Example. You can actually download the book today. It was written, I think, in the late 90s, just on the tail end of Smalltalk's popularity. But he discusses tell, don't ask. If you actually just Google the name there, tell, don't ask, you'll find the pattern discussed on PragProg as well. And they compare that with Law of Demeter and other approaches to software design.
Well, thank you for introducing that, Vaughn. So the question is, and where is this piece of code? It's right on SpringSource.com, Spring MVC step-by-step part 3, how to create a domain layer. Now, let's be honest. If we wrote this code, and this is no criticism of the writer of the code. In fact, I appreciate him creating the web page to show how we can do this. But we might say, well, what's the big deal? You know, it's a sample. It's put out there to really show something else. Well, let's talk about that. This is a sample. It's a tutorial. And so people are going to come out here and say, oh, okay, the expert is showing me how it's done. And this style of coding, where business logic is in an application service, this is really pretty mainstream. This is how it's done today, for the most part, instead of a true domain model. Now let's come up with a hypothetical example here as to why this may be important. You have a service called the Simple Product Manager, and this is running just fine. Now marketing comes down with a request, says, you know what? As marketing, we want to run a special every Friday, 25% off all products, and we want control of it. And so they decide to create something called the marketing service. And when's it going to be done? Today's Thursday. So the developer thinks a minute and says, you know, it doesn't make sense for the marketing service to call across the network hop to the product manager. It's on a different box, different domain somewhere. I'm just going to copy the code. And so he copies the code over, and everything works just fine. He puts in his if it's Friday, starts with a unit test, right? If it's Friday, 25% off, Mac, and that's working just fine. Marketing's happy, everyone's happy. And then he gets a promotion, he moves on to another group. Then, about a year later, new programmer, business requirement comes up and says, you know what, we only want to discount a maximum of 10% on all products. So if somebody puts in 25%, we just want to cap it at 10%. So the developer says, I know exactly what to do. So he comes in here, puts in, if do a math min, 10%, or calculate the percentage it comes in. He writes his unit test, it works just fine, passes, QA passes it. And then a couple days later, president of the company comes storming down the hall saying, we just lost $100,000. What happened? I thought you implemented this fix. So, well, we did. QA passed it. We got a unit test, proved it worked. But everybody forgot about the marketing service. It was Friday. So so when we copy the anti-pattern of copying code, those are the kind of things that happen. So that's why we say it's not really wrong, but we'll just say it makes a better domain model to encapsulate that within the domain object itself. Now there's some questions that have risen along the way by people I respect a whole lot. These are both by VMware professionals, one of whom is in the room. But one is, I don't use domain-driven design because of Spring tools that require setters. So I just new, set, and save. Just like, sort of like what we saw. Another said, well, you know, I want to use DDD. I like it, but I also want to be productive. I want to use test-driven design. I want quality. So how do I use DDD with test-driven development and maintain productivity? So the question is, how will we address these questions? We're going to look at NanoTrader. Now, you saw the opening slide, NanoTrader. This is a courtesy of Brian DeSole's blog. Here at the bottom, the picture. So VMware created these with the blue borders with SQLFire here at the bottom. And what EMC did with NanoTrader, we extended it for the financial services marketplace. But we added an algorithmic trading service within the application services. It's got GemFire. Here, I was the lead on this project, working closely with credit to Brian DeSole. And for the to do the VWAP analytics, VWAP, by the way, is volume weighted average price. It's a very, very common analytic, but it's non-trivial, and so that's what we wanted to demonstrate in the financial marketplace. So what we have here are quotes coming in. We have a domain object called a price quote, and then thanks to the capable people at SpringSource, Spring Integration, they created a quote bar aggregator for us that just takes streams of quotes and aggregates them into quote bars. A quote bar is a beginning and an end. It might be time, might be number of quotes, might be certain volume that you want to cap at, but it has open, high, low, close prices within, say, a 1 day period or a 1 hour period. In our case, every 100 quotes or 2 seconds that go by, we're going to create a quote bar. Then we send it on up into the VWAP analytic. It calculates its analytics. And whenever the price quote is less than the calculated analytic price, we're going to send out an order of 100 shares. And we do that only when the inbound order, we'll demonstrate this in just a second, when the inbound order is greater than or equal to 500 shares. So let's say you want to buy 1,000 shares of VMware, but you don't want to do it right now. You only want to do it during the day when the price gets lower and your computer's trading for you. And then that excuse me.
That's not my eye.
That's a really creepy eye. But, we'll get to that eye in just a second. And then that slice order comes out to the New York Stock Exchange Technologies Trading API, where this application will ultimately live in the NYSE cloud. And it'll get filled. So what comes back is a domain object called a fill. Then the fill gets sent up to the algorithmic trading service to determine when is the order done. Or have we finished our 2,000 shares of VMware? And then we also send the quote bar down to SQLFire so that as you're looking at the screen, you can tell what the current price is. So let's look at what we're about to, let's demo what we're about to look at here. So what we just saw was the VMware NanoTrader, now called SpringTrader, cloud reference application, and then in a partnership with VMware and EMC Consulting and the New York Stock Exchange, all of us collaborating, working together as a team. Well, EMC produced the financial services reference application with VMware, and then we're deploying it to the New York Stock Exchange. But what we're going to do with this is we're going to examine selected code samples in this application. Now, not in a creepy way or not in a critical way, but in an open sort of way. Is this really the best way of doing things, or are there problems associated with it? And we'll open it up to questions. So let's demo NanoTrader. So I've already launched all the SQLFire and the application, but I'm going to start up the quote feeder. Here, run the quote feeder, and so you'll see it. What we have here is a quote feeder just banging out quotes, and then I just show here on the screen when a quote bar is released. Now we have 100 symbols in the application, and every 100 quotes or 2 seconds that goes by, we're releasing a quote bar. So every line on the screen represents about 10,000 quotes that went by every half a second. So we
random numbers yet? No?
they're pseudo random. I do follow a curve, but I introduce little randomness within the curve. So you'll see the numbers varying randomly, but you'll see them go. I have it go as a wave pattern every minute, so that the application you can see that.
Reflecting the stock market.
Yeah, reflecting the stock market. So it only buys low, and buy low, sell high.
Last night, by the way, we made $3 million over dinner.
Yeah.
It was pretty good.
Yeah, so you too can modify NanoTrader while you're programming during the day. Your iPad can be trading for you, making 3 times your salary.
Or 3 times under your salary.
or you'll be working long past your Social Security retirement. So we're going to go in and create a new account here. Wes, password confirmation, Wes. username Wes, opening balance, let's give ourselves a lot of money here. Credit card number, 123 main. Okay, now we're going to register. I have an account called Wes, and the application, we have no holdings. We have $10 million, and recent transactions, we have none. So we're going to go over here to trade. So the way NanoTrader is set up, if we, let's say we want to trade VMware, we'll get a quote. It's 111.75. I'll hit get quote again. You see that it changed. So the quote bar is going down into SQLFire distributed database. Very, very, very fast. So when we buy under 100 shares or under 500 shares, the SpringTrader reference application just completes the order. You immediately got 100 shares, and there it is. And you lost $75 on that deal. Let's trade algorithmically. Let's trade 2,000. Excuse me. Let's trade VMware again, and we'll trade this algorithmically. And the reason why I'm showing you this demo application for a discussion of domain-driven design is we're going to turn it over to Vaughn in just a second to go through the code of what we just have seen. So let's trade 2,000 shares. Now we don't have a holding here because it's being traded algorithmically. I'm going to go to the console here. And so what we're doing is we're waiting. Now this is what's called the broker API, the trading API. When the price gets low enough, we're going to start seeing this console spit out trades in financial exchange format as if it were going directly to the New York Stock Exchange. I didn't catch the price at which we bought. Anybody catch that price?
We can put that feature on the backlog.
Okay, here we go. So we're trading algorithmically now. When the volume weighted average price is it's being calculated analytically. This is all through GemFire, in-memory distributed cache. When the price is lower than the volume weighted average price, we issue a buy of 100 shares apiece. So it's like rapid machine gun. Then you see, and we're almost at 2,000. Okay, and there it'll stop. So now so throughout the trading day, when the price dips down, it just those are called slice orders. So that's what EMC Consulting has done with NanoTrader. Let me stop the quote feeder. Okay. And so now how do I continue this without going back through all the slides again? I think I'm stuck.
The little widget right next to the 59%. Left. That should do it.
Oh, thank you. All right. EMC. So just in closing my participation, this really isn't intended as an ad. It's intended as an explanation because at the booth, we're one of the gold sponsors of this event. But almost inevitably, people come up, almost universally, people come up and say, EMC, well, you're disk storage. Why are you here? Well, it's 40% of the revenue of EMC is actually EMC Consulting. It's just EMC. And so we partner with VMware to offer various services. And so that's why I'm here. And under Stay Connected. The SpringTrader source code was just released late last night, and it's on github.com, vFabric SpringTrader. So the whole reference application of what VMware did is out there for your consumption. Well, let's give attention now to Vaughn Vernon. He's a domain-driven design practitioner who hangs out with the DDD leadership community. And let's give our attention now to Vaughn as he analyzes the code of what we've just seen.
So just to provide a little information about my book, it is based on the work of Eric Evans. So Eric came out with domain-driven design, tackling complexity in the heart of software, which many of you are probably familiar with. I think the book has been around now like 8-9 years, something like that. So you've probably at least heard about it. I highly recommend that you get that book. It's what I consider probably something like a timeless kind of work, because it can be applied to a lot of different platforms that you may be using. There is really no limitation per se with how you can use domain-driven design, other than the fact that you really need to use it properly. And my book is more about answering the how-to questions. Usually when you go out into the DDD community, you'll see, like on the DDD Yahoo group, the same kinds of questions coming up all the time. How do I do this? How do I do that? And unless you have a perspective of, like 20, 30 years in the industry, you may not have seen these patterns used over time. And you see the beauty of DDD immediately when you start reading the book about, ubiquitous language and so forth. But how do I actually carry that out? How do we implement it on a project? And that's what my book does. So if any of you guys are on Twitter, you can find me at Vaughn Vernon, and you'll see any news about my book and other classes and so forth. What I wanted to do is just talk about, a lot of this is going to be my perspective. So you could actually, if you went back like 21 years from now, when I started working with Smalltalk, I already had, like 10 years of experience in software development by that time. So I've seen a lot of trends, and so when I introduce a thought here, just say, you're welcome to say, yeah, that guy's really old, because you carry baggage with you over the years, and when you see different styles of software development, you kind of say, now why are we doing that this way, or why are we doing that this way again? And so what I have found is that domain-driven design really helps projects get it right, but only if you use domain-driven design correctly. So this is, what you're looking at here is the essence of DDD. If you were to kind of like boil it all down, and I think if you talk to Eric Evans, he would say this too, if you boil this all down, this is what DDD is all about. You have a bounded context, and a bounded context is, at a 30,000 foot view is where your domain model lives. And this domain model is not an enterprise model. It's not an all-encompassing model of the business. Even if you do insurance or medical or whatever your domain is, the bounded context doesn't try to capture all of that. The bounded context should really be, if you're approaching DDD from a kind of standards perspective, I guess, you would say that a bounded context holds actually probably a small, really well-defined domain model. So we're not trying to find a way to couple to, the accounts of an individual who's coming in to buy insurance, or an organization that's buying insurance for their properties. What we're really trying to do is model something very important about the business that you are working in, or the domain you're working in. And that's where this ubiquitous language comes in. And the ubiquitous language basically helps to define where is the bounded context in this for this particular model. How far-reaching does it go? How many, entities, so to speak, do we have in this model? And how do we know whether this entity belongs in the model or whether it belongs elsewhere? And when you start to engage with domain experts, you're going to learn a lot about the language, and you want to try to capture the mental model of the domain expert. Now, as you recall, Wes introduced himself as the domain expert in this exercise, and by definition, you actually can't do domain-driven design without the involvement of a domain expert. So, as I'll illustrate in a moment, DDD is not about the aggregates or the repositories. I've heard of people saying, yeah, we're doing DDD, we use a repository pattern. And that practicing DDD is not about picking up one or two or a few of the tactical patterns. This is really the essence of it right here, is getting the model correct. And I think we can demonstrate how today how the model of a true DDD bounded context comes to light as you have discussions about the domain. So another thing to add here is that when someone says about using DDD to carefully model inside the bounded context a ubiquitous language, model is a verb. Sometimes we refer to the model mostly in the noun sense because we take, let's say, like a data model from a database and generate what we might call a domain model. And that's really not what we're talking about. We're not talking about an anemic model. When I say model, I'm usually using it in the verb form, where we are actually, as a team, executing on design. And the design is in code. It's not about, drawing diagrams. It's about writing code and delivering code. So again, this is not what DDD is about. It's not about the entities, value objects, aggregates, events, services, and so forth. These are all tools that help you do precision modeling, verb, using domain-driven design. But again, the first thing that you have to get right is the bounded context and the ubiquitous language by interacting with actually including one or more domain experts in your team of developers. So, how many of you here have actually used DDD to some extent? Okay, wow, that's pretty good. So, if you look at out there, some guys or guy framed this terminology, DDD Lite, where they said, you know what, we actually do find the tactical patterns of using entity, value object, repository. We find those patterns very useful. And so we're going to say that you can actually use those patterns without engaging with domain experts. We can sort of, read requirements and talk to a few business analysts, but from that we're just going to use the precision design tools. And what I'm going to demonstrate is, you kind of might view those as a silver bullet but this is often what happens with the last D. You know, you're gonna kind of step in it if you're not careful. So don't want to leave that image with you for too long, but just remember that that's sort of what you're going to get into if you view DDD as just a set of tactics. With DDD, then, there are two mindsets. There's the domain expert and the developer. Do you have any idea which brain is the domain expert and which one is the developer here? I like to have a little fun with this, but I think that the sort of reddish brain is the domain expert because they're seething mad. They're like, why can't the development team do what I ask them to do? And why is it that, you know, I never get the software that I envision? And the blue brain could be more sort of like the developer because they're starved for, you know, sort of like the oxygen of domain expertise. And normally that's the case because of this. There's a gap between the mentality or the mental model of the domain expert and the developer, and with this pile of requirements that come into any project, in between that is usually an interpretation. So the domain expert engage actually not with developers, but they engage with business analysts, and the business analysts come up with these reams of, you know, use cases or user stories, and they're usually interpreted. So, you know, if you think of the game telephone, by the time that this gets to the developer, it's no wonder that they don't know what the domain experts want exactly. They may have some idea, and the software does roughly reflect kind of what was desired, but they are not engaging directly with domain experts. And so when you look at what the domain experts think about, and this is a domain I recently worked in, it's basically called SCHIP, or State Child Health Insurance Program, I believe is the acronym, for states that offer medical care for children of kind of disadvantaged families that don't have a high enough income to pay for their own insurance or pay for medical. So, you know, domain expert is really concerned about the family, what the application of the family reflects about them, their income and their expenses. The demographics of the family then becomes a very big concern. The special needs of the family. What about tribal membership or the lawful presence of the individual in the United States? Do they, you know, should they be permitted to get this insurance because of their lawful presence or not? They're concerned about the account of the family, the eligibility, and the enrollment. And so these are business things, right? These are things that the business is really concerned with. And when we look at these business situations, we want to model carefully the most important aspects of that. And there are times when the model that you develop should be crud-ish, you know, just a simple data-driven model. But there are probably places in every business domain where we do deserve to use a really carefully crafted domain model as a source of solving this problem. And notice here too that this domain expert has the ability to think in different kinds of fonts. Okay, so that's important. Did you notice that? Whereas, you know, when we come over here to us, if we're not helped a little bit by domain experts, we actually only think in Courier. Courier New, to be exact. And you know, we're concerned about the loops and the binary, and we like cool things like AJAX and BPEL, and I probably don't even have the most modern acronyms up there of the things that we're interested in, but this is kind of like how we think. And so we can actually learn to think in multiple fonts, but we have to engage with domain experts to do that. And this is how it happens. The domain experts have to, kind of mind meld with us and help us to see what their mental model is. And we want our software to reflect the way they think about the problem. And really the only way to do that is to interact with the domain experts like I did with Wes on this project, because in order to get algorithmic trading right, and specifically VWAP and understanding VWAP, you have to understand the terminology. But it's not just about terminology. There are thoughts about the processes. And as you actually have discussions with domain experts about the business process that takes place, that helps us to actually, mine out additional modeling opportunities. Again, model being a verb here, because we're actually taking what's in the mind of the domain expert, like Wes in this case, and transferring it into code and reflecting the way the business should really work. And what you'll find also is that this is actually a two-way street. Notice that the arrows don't just go one direction. It's not like we're being, indoctrinated with the thoughts of domain experts and we have no say in it. By this interaction, the domain experts actually learn a lot. And I can tell you on this project just a few months ago, I was in the room trying to justify DDD to some domain experts, and one domain expert was a little miffed about having to spend even an hour in the room with us because he really didn't have time to do this. And so what happened is, I'm sitting there trying to explain the value of DDD, and I kind of encouraged him just to be a little patient for a little while. And I'm telling you, within an hour, he had an aha moment. And he said, oh, wait a minute, are we talking about, and in this case, we don't even see the term up here. He said, request for coverage, and I said, I don't know, what is request for coverage? He said, well, in the state of Georgia, we lost our shirts because we didn't understand what request for coverage was. And request for coverage became, this key theme in our discussion all of a sudden, because we realized that this was an important part of the model that didn't get delivered with the software, and it cost the company money continuously, month after month, because they were dealing with not understanding request for coverage, not being able to even track a request for coverage within the lifetime of the fact that eligibility and enrollment, had to process, and where is this particular individual or family account right now within the request for coverage time frame. And that was the aha moment. And when you have a moment like that in these discussions, you realize this is what we call a core domain in DDD. That request for coverage is most likely not just an entity that we're going to tack on somewhere in a pre-existing model, but there are probably enough interesting business processes and data that's locked up in that idea in the domain expert's brain, who knows, because he worked in the state of Georgia in this project and said, man, if we had only had this, and the business is suffering right now because we didn't have this, and how we could use this to leverage, the ability to win new business in other states if we had requests for coverage. And then you realize, okay, this is most likely, maybe not, but most likely a very cohesive model that we can do a lot of business good with by mining out what's in the thoughts of the domain expert and putting that into a domain model. Now, usually in the projects we work on, there's a lot of what we might call brown. Brownfield development. Sometimes it sits in piles, and And how do we deal with this? Well, you know, green can grow out of brown, so that's a good thing. And we certainly want to leverage the legacy. And if legacy is a little bit more desirable in your environment, you maybe even feel, you know, brave enough to call it heritage code instead of legacy code because it's a good thing, and justify it in saying that. But, you know, in one way or another, we're dealing with this. How do we deal with that in DDD? Unfortunately, there's no such thing as the code fairy that, the green code fairy for that matter, that comes along and makes all the brown green, and, you know, we get to rewrite everything. We say, you know what, like in 6 to 8 months we could have a brand new model that uses DDD, and we can make all that brown just go away. That unfortunately doesn't work for us. So what we're looking for is a way to come up with that really well-crafted model where you have nice straight rows of green like we see here. And you have any idea where the brown is in this photo? Yeah, you probably realize it's right there. So there are patterns with DDD that help you to deal with the brown, you know, in a way that you actually mostly don't even have to smell it or you know, step through it or anything like that. You may have to for a short period of time, but you can actually go and make that nice green field with straight rows, and you look at the model and you say, wow, this is really good stuff. And look, you know, we even have that sort of place where we hide the stuff that we don't like to deal with. And so there are patterns for that with DDD. So what I'm going to do now is just go through kind of rapidly how we can use the strategic design patterns and tactical patterns within DDD. So again, the bounded context with ubiquitous language is very important. It's the most essential part of DDD. And then we also have this thing called context mapping. And with context maps, what we can do is shelter the brown. So like the accounts context up here is in an accounts domain model, but let's say that that's legacy, and you know, accounts have been around for ages, for decades. But how do we interact with that to develop this new equity trading context that's on the bottom? Well, you see the question marks there. Those are the patterns, sometimes organizational patterns, sometimes software patterns that exist between these two contexts, and one is upstream and one is downstream of the other. That's the U and the D there. And how does that upstream influence have an effect on the downstream model, and how do you deal with those concerns? So this is really reflecting the idea that we do have multiple models. In fact, potentially, you know, several models in a DDD kind of environment. And the relationships that I was talking about down here are listed there: open host service, published language, anti-corruption layer, customer-supplier partnership, conformist, shared kernel. There's also big ball of mud, which is, you know, a pattern. It's a fact of, you know, that we have that brown sitting there. So those are two really important parts of strategic design with DDD. And here's why. Because this is what existed when Wes and I started working on this. NanoTrader, and here are the quote feeds, and this is pretty much what we had to work with. And we kind of treated this as a legacy system or a heritage system, as, you know, it's a good system, but we weren't going to try to go in and implement algorithmic trading within this model. We felt that, you know, this was significant enough that it actually formed what we call in DDD a core domain. And so our new modeling would happen down here. It was a smaller model, we didn't have to manage accounts because accounts were up here. Actually, the holdings are up here. Actually, the orders are tracked from here. So when you have an order of 2,000 shares, it's actually created here. It's fulfilled here, and we do have a kind of order going on over here, but it's not the same order that we have here. And we have different modeling concepts here. So again, this is how we would use context mapping, and you can see that algorithmic trading is a downstream model, so this model has an influence on this model, right? So that's context mapping with separate bounded contexts. What about architecture? I'm going to go through these really quickly, but I have to say that when people get into DDD, they kind of say, well, architecturally, DDD is kind of behind because, you're kind of stuck with a layers architecture. And that just actually is not true. DDD has probably the broadest applicability across architectures, or you can use many different architectural influences in a DDD setting. So yeah, we do have the layers architecture, the typical, this is a relaxed layers architecture where we have a UI and application layer, the domain layer that has the domain model here, and these are the transactional kind of task management services up here. But our carefully crafted model is here, and then we also have some infrastructure to help us do technical type stuff. Using a more modern way of looking at this, we could take the solid principle of dependency inversion principle and kind of turn the model, upside down a little bit and make the infrastructure actually dependent on all these other things by the infrastructure implementing the interfaces that are defined in these lower layers. And so actually the way some people look at this is that there are only two layers now with DIP, and you have an infrastructure layer that implements the interfaces in an application layer here. I break it out because I really see these as distinct things, but you might view that a little differently. Hexagonal architecture is an architecture that I think is probably more enduring than DIP or layers, and it really includes a lot of those thoughts. But if you go out to Alistair Coburn's blog, and probably know Alistair Coburn as the writing effective use cases guy, and so he talks about hexagonal. Some people call this onion architecture. There's not a lot of difference between that, but the really cool thing about this architecture is that we can craft our domain model in the very, very heart of the software. We have our application or our API around it, and then we simply have a number of ports that take input from different kinds of devices or human interfaces or whatever it happens to be. This could be a browser here, this could be a phone, this could be, whatever, some other kind of client. This is maybe messaging. But each of these things has a matching style of adapter. For the UI, this could be a set of controllers, but it's an adapter, okay? And this for the phone is a different kind of controller. Maybe it needs to deal with things differently. This is a messaging handler that's registered. Maybe we have RabbitMQ feeding in here. And these adapters are used to simply put all of this input from various ports into the application API that is exactly the same for all of these ports. So we don't actually have a different API for telephones or for cell phones versus web browsers versus messaging. For the most part, we have one API that sits right here that's actually very thin. These are your application services, and it only then delegates the tasks, the actual use case flows into the domain model. And this is where the real magic is in here in our domain model. And likewise on the going toward the outside again, we have adapters that are like our repositories. Maybe this goes to a SQL database, maybe this one goes to a key value store, maybe this one here is an in-memory, a grid like our Fabric like GemFire, and this is where our messages go out through RabbitMQ again. And so I think that the hexagonal ports and adapters architecture is a much more fitting one. And if you ask, well, what is really the difference between that and layers, is fundamentally you have just an inside the application and an outside of the application. And when you start thinking about adapters having to adapt to an API, it helps you to realize that you're not going to necessarily implement new APIs to take on a different kind of client, and it helps us to keep our application code really clean. We also have, we can apply hexagonal to a service-oriented architecture where we simply add in here a service registry, and then we can support, REST, SOAP messaging, whatever these adapters are adapting for REST, for SOAP, for messaging, and they're just simply putting those requests into an API, services here that again are reflected into the domain model. You can use. Go ahead.
Would you go back?
Yep.
Is that a good representation to say the domain model is fully surrounded by the application, so the adapters don't know about the domain model?
Yes, I would say. Well, it depends. Actually, I'm working on a project right now where I kind of, it's an actor-based approach to, or actor model, where it kind of like folds everything together and greatly simplifies the layers. So you could actually say that there is a way of making the adapters adapt internally, and you don't actually have to see all these things going on, but the domain model just sort of appears to receive these requests, directly, but it's still abstracted. But
I wonder the adapters should use the domain model.
I would say, I mean, it's a really good question. I just think that what I'm presenting here is Alistair Coburn's vision of ports and adapters, or hexagonal. I would say that maybe the adapters could go there, but then really what we're saying by that is that the API lives in the adapters, and that doesn't necessarily allow you to take on a new kind of adapter, because the application layer allows you to take on security and transactional control here. So we don't actually want security and transactions going on here, and this just allows the API to put things into a context that the domain model can deal with. It's very thin. So when you look at this, don't think like a lot of code here. We're really just talking about each method maybe having 5 or 10 lines of code. Well, and that's good design anyway, but I'd be glad to take that discussion offline and describe some more details about it, or maybe we'll have time for questions after. CQRS, or command query responsibility segregation, I'm not going to talk a lot about this, but it's a way of dealing with the fact that our views tend to have a lot of different, they look differently than our aggregates, our entities look in our model, in our domain model. So what we do is we split the command kinds of requests away from the query kinds of requests in 2 different interfaces, and we are allowed to query from a different model to satisfy the complex view, but still use a domain model only for commands. And by building 2 separate models, we can use these effectively, to our best advantage. Instead of having to go to this command or this traditional domain model and create all the queries that we need to get all the data that cuts across the various aggregates that are here, and find a way to get those all on the screen. These tend to work against each other unless you just go ahead and separate them.
Vaughn, you may want to define what an aggregate is, because that's a new term.
Yeah,
you just
I'm actually getting to that pretty soon. But an aggregate is, you know, a globally unique entity that has a meaningful whole that has a cohesive set of other objects, potentially like value objects or maybe other entities that help you to model a specific concept of the business. So we can use hexagonal again in an EDA, and we're going to talk about our EDA for NanoTrader here in a few minutes. And we have things like long-running processes, so we can have a, you know, pipes and filters approach to event-driven with event-driven architecture, and have these events you know, provide input for filters, and the filters create new events until, you know, the final thing happens. And this can be concurrent processing, so we can split, you know, off one event can have two different or many different forks. We can, you know, fork our process and join back here in an executive. We can use this kind of approach with DDD. And, you know, guys like, well, Greg Young has just come out with this thing called Event Store, a really simple name for allowing us to very easily implement aggregates that support event, that are themselves event-centric, event-driven, and the events actually make up the state of your entities or your aggregates within your application, and your repository or the thing that you use to go get your aggregate the aggregates are reassembled from individual events that have occurred on the aggregate. So this is actually really, really advanced stuff. If you think that DDD just ties you to layers architecture, it's just untrue. In fact, I think most of the innovation these days is truly happening within the DDD community, and there's a lot of really good, powerful, interesting thought happening around how can we make using a domain model easier and more powerful. And this event-driven kind of approach is very important for you know, other aspects of the model we'll discuss again in a moment. So we can also use GemFire, SQLFire, a grid or a fabric type of storage, and take advantage of the GemFire functions, you know, to act as our services. So DDD is really applicable here because we're storing domain objects. We're storing domain objects in the fabric, right? Just look at it. Your domain model is persisted, serialized and persisted into the fabric. It's a really natural way of actually storing aggregates because, you know, as Martin Fowler recently coined the term, that NoSQL stores are really aggregate stores. So if you've read his recent book, NoSQL Distilled, or heard about it, you probably should read it. He discusses in there that you know, aggregate store is a really important point, and that's what we're talking about, is storing aggregates of a domain model. Okay, so tactical design tools. These are not the essence of DDD, and I've already made that point, but they are important. So this is an aggregate. Inside a bounded context, we actually start to model now our concepts into separate boundaries where we have a number, maybe one or more entities, like this aggregate root is an entity, but it may have other entities that are only available through root access. But we also want to emphasize that value objects are extremely important, and probably even more important than aggregates other than the aggregate root. If you really look carefully at value objects and you understand the power behind them, even the functional programming approach to value objects, even if you're using an object-oriented model, or developing an object-oriented model, value objects, you'll start to see that everything starts to look like a value object. Like a couple weeks ago, I taught my class in Bogota, Colombia, and the guys tweeted after the class, I went back to work the day after the class, and now everything looks like a value object. It's very powerful stuff, and you can test them and reduce the number of bugs that you have by using value objects. So this is kind of the aggregate idea. Let's move on. Domain events. Yes.
Can you give us some more practical example, like aggregate? Is it a account, is it a client, or is it a company?
Oh, okay.
Vaughn,
yeah.
since we're being recorded, you may want to repeat the question.
Yeah, so give some examples of an aggregate. So this aggregate could be, like, let's say that this aggregate is the order in NanoTrader, and this aggregate is the holding. And we may have another aggregate that's a count. So they're persistent things, and you have a globally unique identity associated with the aggregate root, which makes, this entity type is different from this entity type. So this is the order entity, and this is the holding entity. But within those, you can have a graph of other objects that are, so this is the thing that you would persist using Hibernate, for example, or this is the thing that you would use its unique key in GemFire to store, and then you would serialize this entire little grid here, or graph, I'm sorry, this little graph, and put that into the fabric with the, so the key value pair. The value would be the whole serialized object, and the key would be the unique key of that particular instance. And then you would probably have a region where you would, not probably, but you may have a region for these kinds of aggregates. So all of your orders would go into a GemFire region called order region or something like that, and this would be the holdings region that contains all of the aggregates of type holding. Okay, but it's a persistence concept. But what you're really concerned with aggregate is, what are the invariants? What are the true business rules? So what has to be transactionally consistent needs to be within one aggregate. And I have a whole 3-hour series presentation on this that's available on dddcommunity.org, and a paper. It's a 3-part paper, and there are 2 videos out there that talk about how to effectively design aggregates. It's been discussed in the New York City DDD community and so forth. So, it's quite an involved subject, but it can be made simple by just following like 4 simple rules of thumb. Okay. So domain events. These are the facts about what has happened. So think about your aggregates, your these meaningful holes that model some specific business concept in your domain model. And when something happens to them, like you execute a command method on the aggregate, a business method, we create an event that says, what just happened in my model? And then we publish that event. And that event can now go out to various kinds of subscribers. We can even have a subscriber that keeps every single event of every single aggregate instance in the entire model for all times. And we can go back and look at those events later analytically. But right now, we may use them today in an event-driven architecture. And the subscribers out here could be other bounded contexts. It could be aggregates, per se in our own model. So this aggregate could have an eventual consistency influence on another aggregate up here by it basically getting that event. again, like I said, facts forever, and because we have an event store here, we can both forward events through like RabbitMQ, or we can package them up into the notification logs and have them accessed through a RESTful resource kind of environment. And we can look at these facts anytime. We can go back to the very first event that ever occurred, and we can look at that 5 years from now and publish it again. We could publish it again from here. We bring up a new bounded context, and we find out, you know what, we need events that happened 5 years ago. We didn't even realize why we kept all those events 5 years ago, but now we're going to republish them because we still have them, and we know when they happened. And now you have the facts about your big data. So, you know, when I hear these big spiels about, oh, we got all this data, we got petabytes of data, and we're, you know, and I say, you know, one thing you're probably missing? What? The facts. They say, what do you mean, the facts? You know you have the data, but you don't know why you have the data. When you look at that data and you run analytics on it, to some degree you're making assumptions about why this data exists, and you don't know the shape that that data was in at one point in time, at any point in time. You just have this snapshot, bang. Right now we have this big data and we're going to analyze it. But if you had the facts about it, how powerful would that be? So seriously, if you're interested in this event sourcing approach, go out and look at, and you don't have to use event sourcing to do this. You know, you maybe are using a different approach, but look at storing events. Keep your facts forever. Value objects. This is one reason why this team down in Colombia said, you know what, man, everything looks like a value object now, because I stepped them through this idea of, you know, just using value objects that are immutable. We can actually make a copy in our test. So this is a test. I make a copy. I create a business priority. Okay, this is a business priority concept, and then I immediately make a copy of it, and I have a business priority copy. Okay, and then I can immediately assert that these two things are equal. I can then create this business priority totals concept, right, an instance of that, and then calculate a priority of this business priority based on the totals. And this is actually from a backlog. Okay, these are a number of backlog items in a Scrum sprint, or not a sprint, but in a product. This is a product backlog, and so we can calculate the priority of any business priority relative to all other business priorities, and then we can assert that this is the right, you know, value. So that's our test. But look at this now. Look at this final powerful piece of code. We again assert that our business priority and our business priority copy are equal. This means that this operation did not mutate, did not modify our business priority object. And when you know, and this is just really scratching the surface of value objects. I don't want to say that that's the limit of it. By no means is it. But when you start looking at things in this way, you're going to save yourself a lot of grief, and you're going to find out that probably most everything in your domains are value objects. Oh, and here's one of my favorite things. I'm kind of transitioning now from the way to use DDD to, you know, sort of like how a lot of people write Java code these days, or any code for that matter. So this, yes?
The previous slide you have asserted that the copy is the same as the original object. So what was the purpose behind displaying or asserting that thing? Was it, you talked about immutability of objects as well as the value of this. Why are those two related?
Oh, because what we're asserting is that in this line of code is that this business priority that was created here was not mutated. So actually in every single test that I write for this business priority object, and for every operation that I test, I not only assert that the test itself, that the business function worked. So this is functional, right? We're not mutating, we're simply returning a new value. I not only assert that the answer was correct, but I assert that I did not mutate. So I'm testing to make sure that my business priority is in fact immutable. Okay?
Just to make sure the map doesn't change anything.
Exactly. Exactly. So, I mean, not that you necessarily have to do that, but I'm just illustrating this, that value objects are immutable. And if you need a new business priority, what you can do is say business priority dot, with new risk, something like that. And now you just take the original internal attributes of this and only replace the one that you needed to replace, and you replace the whole value. So you're not modifying this object, you simply do a whole object replacement. And that's a functional approach, right? So you don't have to be using a functional language to do functional programming. So this is one of my favorite slides. This is actually my sample Java constructor. I'm going to check my time here. Do you guys get it? This is my sample Java constructor. Why don't we write constructors anymore? I mean, so there's not even a constructor in the class. We just use the default constructor, which is a zero argument constructor, and then we just set a bunch of attributes. I mean, how do we know that that's the right thing to do? Constructors are a really, really powerful object-oriented approach to developing software, and it allows the object itself to determine what state it takes on. Without a Java constructor, and by using sets, it is the procedural way of developing software. It is not the object-oriented way of developing software. The constructor allows us to tell, don't ask, instead of making a decision on behalf of the object and just setting data on it. So think about what you could accomplish by just instantiating objects through their constructor with the entire first state that they should have. So you asked earlier about the abuse of the Java Bean spec. Now, again, take it from an old guy. By so back in the 80s, I started developing software in 1983. I got paid for it back then. And then toward the mid to end of 80s, I actually attended one of the first C++ user group meetings in New York City. There were like 5 people there. It was, I remember it was right after I got married in 1984, and there were like 5 people there. And here's this guy, was it Greco? Anybody recognize that name? I mean, I think he's still there, big influence in New York City. And he's like, C++, and half of us are kind of like, this sounds really cool, but man, well, we were actually doing object-oriented programming with C++ and Smalltalk in the 80s, and I started with it with Smalltalk actually in 91. I started with C++ about 87 or so. And so here's what, an old guy's perspective on this. In 1991, I also saw, the fact that Windows 3.0 actually made a difference at that point. And Visual Basic came on the scenes. Properties and property sheets, wow, those were powerful. We could just drag and drop these things onto a form and fill out some boxes, some fields, and we had a working program pretty much. That was pretty powerful stuff. And so that had a big influence. From 92 on, you saw visual C++ take on ideas like this. And then by 96, the Java community started asking, how in the world can we capture the same kind of, community interest or the, the power behind Visual Basic and make Java work a lot that way. Oh, we got an idea. It's called the Java Bean Spec. Yeah, we can allow UIs to be assembled really quickly. After all, it's 85% of the complexity of writing an app, the GUI. So let's do Swing and make the capability to make Windows look the way that or reflect the way that a property sheet is filled out. That's cool, or several property sheets. Well, from that, this Java Bean Spec started having a lot of influence from 98 onward, and then look at the first version of Hibernate, right? Hibernate, I think I started using Hibernate like in maybe 2003, and I looked at Hibernate and I said, why is it that you have to have a public setter and a public getter for every single attribute in Hibernate? It just doesn't really make much sense to me. And because I had written my own OR mapper a few years before, and I just did direct field access. But I think it's this influence where, hey, the setter is there anyway, let's just use it, kind of thing. Let's use setters in the same way that we modified properties in Visual Basic. And essentially what we've done is completely broken the object-oriented paradigm. And why do we even have those? Why don't we just make our attributes public? I mean, for the most part, are we really accomplishing anything by having getters and setters? I mean, go look at 99 and 9/10 or more % of all property accessors or attribute accessors in the whole earth, and all they do is say this dot, attribute equals something. That's it. There is no domain logic in any of those things.
I would say that decision of having all these fields private is really a function of language, not having the first best practice.
Well, yeah. I mean, I agree that .NET, did that better, the CLR. But yes. Okay, so let's move on. That's my perspective. We probably need to now just take a closer look at why this is so important. Anemia everywhere. CRUD loves anemia. I love this slide because actually, from an object-oriented perspective, I always say, save customer from what? A flood? An earthquake? Save them from a heart attack? Oh, that's right, we're doing CRUD. So I have all these, completely separate kinds of attributes here, and I'm just going to run a bunch of if statements here. I'm going to say, well, if this is null, then I'm not going to set it, but if it isn't null, I'm going to set it, and I'm going to assume that if the customer doesn't exist yet, that means I want to create it. And then you find out that 20 different use cases use this, and you can't figure out actually even how to test this. You have to write 100 tests for all the permutations of the possibilities of mutation here. And instead, if we created an intention revealing interface that allowed us to do different kinds of things according to the use cases that a customer is used in, this is the kind of model that we would come up with, and we would do something simple like this, like have an application service that changed the personal name of a customer. So let's now look at this NanoTrader stuff and how DDD was used. So when we also had, we took this NanoTrader domain model, and we needed to do some very simple, a little bit of rewrite and a little bit of really more refactoring, because what we found is that the things we needed to do to make our new domain model, the algorithmic trading model, work, we had to just do something like this. We had to add this concept of a business ID, because this order ID didn't exist until the commit was done. So when this order was committed, this ID showed up, but it wasn't there in time, because actually in the constructor we needed to publish the event order placed. So we needed a new business ID. Just think of this as like a very unique, per instance, business key, like a foreign key kind of thing that we can use in other bounded contexts to tie us back to this order. And when the order is completed, we now put a rich behavior on the order that when it's completed, instead of calculating this kind of stuff in the application service, we did it here. And it allowed us also to publish this order completed event. That way, we could do away with this CRUD kind of approach in trading service and actually implement a constructor for order. And as you can see that after we construct, we can actually now publish an explicit domain event that we could not achieve if we were just setting properties, because we wouldn't know that an order was just placed by individually setting like 10, 15 different properties. Okay, so the constructor allows us to do that. And then a holding is created in this complete method. So now the order has a complete method. And again, we can publish the order completed event. And now our holding has a constructor that constructs itself based on the order that was just filled. So now we get over to the algorithmic trading model, and this order in the algorithmic trading, actually I'm going to skip this slide for now. That's incorrect. That's not so important. So what we found is that in NanoTrader there were at least 4 places where the creational stage of an order took place, and now there's just one place. So we use the aggregate constructor to instantiate the order. 95% of the model has been left untouched. Now, in the algorithmic trading model, we found that we were sharing the order from the other system. The order was then refactored so that it would stand on its own. This quote bar aggregator had a missing concept. We had the notion of an algo quote, but it was really a quote bar. So we found that we needed to refactor to this degree. So now we have an algo order which properly matches the ubiquitous language with a quote that's now a value object, not an entity. So this algo order holds a quote. We also have a price volume that's used in calculations. We have this quote bar aggregate that's much better tuned for what it actually does now. And we actually have an order type which allows us to distinguish buy orders from sell orders, which before was not really explicit.
So, quote bar, what is it aggregate of?
The what?
The quote bar, what is it aggregate of?
The quote bar is an aggregate. It aggregates the stock opening, close price, and so forth of a region of a series of quotes.
Like
so over
1 minute
time,
bar.
all these individual quotes are aggregated into a bar. Okay? And so this quote bar aggregator now looks at this concept properly, and we have a clean constructor to construct one of those aggregate instances. We also have this supporting or maybe even generic subdomain called money. Money was using just a raw big decimal throughout the domain before, but all of these interesting calculations were being lost in the procedural code. So we created simply a money value object that did all these calculations for us, like add to, divide by, is greater than, and so forth. That way we can hide all the details about big decimal and make the calculations actually make sense from a monetary standpoint. So this is what we ended up with. NanoTrader publishes this order placed event. If the shares, like Wes said, are under 500, the NanoTrader deals with it on its own. It just grabs, immediately purchases 500 shares, boom. You may lose some money because of that, but if it's greater than or equal to 500 shares, we handle that event in the algorithmic trading. The slices are purchased here, and once the order is filled here, we publish the order filled event, and the order filled event is subscribed to by the NanoTrader system, and this allows us to now reconcile the original order, create a holding, and then place that on the account by allowing all of that to happen in an eventual consistent way. So we're using an event-driven architecture to allow our new algorithmic trading bounded context or core domain to exist here, while allowing this system to stay pretty much intact. So, the question of Spring productivity tools, feel free to leave if that is pretty much the end of the presentation. I know there's a break. If this topic continues to interest you, please stick around. I don't have too much more, but I just did want to make a couple more points. Spring productivity tools. The question is asked, what about Spring productivity tools? Can I use them? And I say, yeah, you can, but there may be ones like Roo and so forth that don't make sense necessarily in a domain-driven design approach, because you're really trying to capture the essence of the domain in a model. So most of us would say, okay, if I said, I'll give you $15 today, or if you come back here tomorrow, I'll give you $20, we would probably most say, I'll take the $15 today, right? But if I said, well, what about in 1 year? If you met me here in 1 year from today, I'll give you $15, or if you meet me here in a year and a day, I'll give you 20. Waiting a year to get the 20 it's a wash, right? Why not just take the 20? And the point here is, if we aren't careful, we'll allow our natural instinct for hyperbolic discounting to allow us to make the fast choice now, the thing that seems to have the quickest reward now, but not looking at the fact that making a software investment over time makes sense, because you can't deliver a complex piece of software tomorrow. It's going to take time. And so if you come back, a year from now, and it only costs you $20 to develop the software in a better model, then why would you choose to take a shortcut where your code is potentially more brittle and doesn't stand the test of time of complex changes over a period of time? So yes, you can use Spring productivity tools. We're using Spring here. We used, I think, just about everything except for maybe Dozer in the work that we did, because we're not concerned about sort of shoveling properties in and out of objects. We're more concerned with the behavior. But for the most part, we did use Spring productivity tools. Well, I think you had plenty of evidence that TDD does work with DDD. In fact, you can actually test objects when you instantiate them, and and they know what their state is. You can actually predict what an object's state should be. So you can test them. You can predict what the outcome of a rich behavior should be. So can you use TDD? I assert you can do TDD much better with domain-driven design probably than you can with CRUD and anemic model approaches. So that's the end of the talk. We probably need to clear out, but I can take questions at the back of the room if you want to talk some more about this. Sorry for a little overtime there. Thank you.